Okay, let's solve the question previous greater element. What does this question say? We are given an integer array. Return the first element on the left side which is greater than the current element, or else return -1 for that element if the previous greater element doesn't exist. So we have previously solved the next greater element and next smaller element, right? This is also almost same, but we need to find the previous one here. So let's understand this with this example. First element is 2. We should check now on our left side. Nothing exists here, so there is no previous greater element, so we mark this as -1. Now we move to 7. We see left side. 2 is lesser than 7, so this is not the previous greater element, and nothing exists, so it is -1. For 5 again, we move this side. 7 is greater than 5, so for 5 the previous greater element is 7. Again same for 4. 5 is the previous greater element. For 3, 4 is the answer. Now for 6, 3 is not, 4 is not the answer, 5 is also not the answer, and 7 is the answer for this. And for 2, 6 is the answer, and for 1, 2 is the answer. I hope you understood how we got this answer. What will be our brute force approach? This is also same. Let me write down. What we do here is 2, 7, 5, 4, 3, 6, 2, 1. So basically we traverse through each element, and again for each element we traverse from the previous index, that is, let's say j equals to I minus 1 down to 0. We compare it with each element, that is, let's say this one as array of j. If array of jth element is greater than our current element, that is array of I, we have found our previous greater element, right? So once we found it, we can break from the loop, and before that we need to store the answer, that is previous greater element of I will be it will be array of j. If we didn't find anything, that is it will be I will be -1. This will be the brute force approach. So let me explain again with this example. Imagine you are at 6, that is I equals to 0, 1, 2, 3, 4 and 5, right? So we run a loop, that is j is equals to 5 minus 1, that is from 4 to 0 we move. So we first check if 3 is greater than 6. No, this is false, so we decrement j and move here. 4 is also not greater than, 5 is also not, and 7 is greater than 6. So this condition is true here, and we assign the PGE of I, that is PGE of, what is the index of 6, that is 5, will be equals to 7. So this will be the approach. What is the time complexity here? It will be O of n square. Why? Because this for loop will run for each element n times, and we move backwards in this another for loop, j for loop, that is again n, that will be n square, and space complexity is O of n for this PG array. That will be it. And now as we solved before for next greater element, we can use a monotonic stack to solve this. This is basically same as that one, so there is slight variation. Let me explain. Let me take the another example. Let's say 2, 7, 9, no, let's say 5, 4, 3, 6, and let's say 2. This will be the array, and what we do is we do the same here. So here we need to calculate which is on the left side, right? Previously we were calculating on right side for next greater elements. That time we started from end, because in the stack we need to store the next greater elements of this right side. But here we need to move from left to right, because we need to find the previous greater. So let me take a stack for this. Let's say this as a stack, and we are at index I equals to 0, that is 2. Nothing is present means it is -1. So we push 2 and move to 7, and we compare again. 2 is not greater, so we pop it, it became empty, that doesn't exist. For I equals to 1, that is 7, also it will be -1. So we push 7 again. Now we move to 5. 5 sees stack top, that is 7, which is greater than 5, which is the next greater element. So we mark for I equals to 3, that is 5, as 7, and push 5 to the stack. Now we move to 4. 4 again, top is 5, 5 is greater than 4, which is valid. So I equals to 4, that is element 4. The answer is 5, and we push 4 to the stack. Now we move to 3. 3 again, stack top is 4, 4 is greater than 3, so this is also valid. For I equals to 5, that is element is 3, answer is 4, and we push 3 to the stack top. Now when I equals to 6, that is the element is 6. See, 3 is not greater than 6, so we pop it. This is not a valid answer. Again, 4 is also not greater than 6, 5 is also not greater than 6. We pop all this, and we are remaining with 7, which is greater than 6, which is a valid answer. So for this, answer will be 7. We push 7, and we push 6 to the stack. Now we move to 2. Stack top is 6, which is greater than 2. For 2, I equals to last one, n minus 1, let's say. Answer is 6. This will be our approach. This is explanation is same as the next greater element. If you don't know how to solve the next greater element, you can watch the video from the Monotonic Stack playlist and see. Now let's code this part. This is simple. So what we need to do is we need to take a empty stack and an array to store the previous greater elements. Let's say that as previous greater element PGE, that is empty, let's say of size n. This will be our use. Now what we need to do is for each element we need to traverse, right? That is for I equals to 0th index to n minus 1. What we need to do here is, now we need to check the previous one until we have two options here, same as before. Either stack will become empty. If stack is empty means we didn't find previous greater element. If not empty means there exists some top element which is greater than the current one, that is PG is found. Okay, that will be while. So we need to pop the elements until we are finding smaller elements. We need to pop those because those are not valid answers. So while not of stack dot empty and stack dot top is less than or equals to current element, that is array of I. We need to pop the elements. This will execute, and once we are done with this loop, we need to check either stack is empty or not. Stack dot empty. If this is true, means if not of stack dot empty, let's take this first. If stack is not empty means we have found the previous greater element. So we set PG of I as stack dot top. Else our stack has become empty here. So if stack has become empty, we didn't find the PGE, right? So PGE of I is -1 here. After all this, we need to push the current element, right? We push it to the stack. This array of I, and we move to the next one. After all this, we can just return the previous greater element. So same as before, time complexity will be O of 2n in worst case, and space complexity is O of 2n again for PGE and for the stack. So I have explained in the next greater element video that why it is O of 2n. I am not going to explain it again. If you don't know how to solve this, please look into next greater elements videos. Yeah. Now next is previous smaller element, right? Previous smaller element. This is also same variation, just we need to change the signs, that's it. So here also we need to calculate for given array, we need to find the first element on left side, which is strictly smaller than current element. If there is no previous smaller element is not there, means we need to return -1. So let's understand with example. Say we have 1, 3, let's say again 1, 7, 6, 10, and set 2. So what will be the previous smaller element here? For 1, there doesn't exist anything, so we mark it as -1. For 3, 1 is the answer, so we mark it as 1. For 1, again 3, 1 is also strictly not lesser than 1, so doesn't exist anything. For 7, answer is 1. For 6, 7 is greater than 6 and 1 is lesser than 6, so for 6 also sorry, for 6 also it is 1. And for 10, 6 is lesser than 10, so answer is 6. And for 2, again 10 is not, 6 is not, 7 is not, 1 is the answer here. This will be the answer. So brute force is also same. Now I'll just explain the monotonic stack approach here also. Previously we were checking while not of stack dot empty and stack dot top is less than or equals to array of I, right? This is for previous greater element. Now for previous smaller element, let me show what this happens. Let me take this stack for same example. So we are at first index, there is nothing, so we mark -1 and push the first element, that is 1. Now we move to 3, we see the stack top, the next 1 is lesser than 3, so 1 is the answer for this, so we don't need to pop and we can push 3 to the stack top. Then we move to 1, 3 is greater than 1, so we pop it. 1 is also greater than 1, we pop it. Now again, now we push 1 to the stack top and we move to 7. We see stack top 1, that is the answer for 7, so we push 7 and move to 6. 6 for 6, 7 is not the answer, 7 is greater than 6, so we pop it. 1 is the answer and we push 6, move to 10. For 10, 6 is the answer, right? So it is at stack top, we don't need to pop any elements, we push 10 to the stack top. Now we move to last element, that is 2. 10 is greater than 2, right? So we pop it. 6 is also greater than 2, we pop that one also, and we remain with 1. 1 is lesser than 2, so this is the answer for 2. That's it. That's it for this approach, and at last we will get the answer for all elements. What is the time complexity here? Same, O of 2n space again O of 2n. This is very simple. So here what changes we need to do here for this question? We just need to change stack dot top is greater than or equals to array of I. Here see, we are popping greater than or equal to elements which are greater than or equals to array of I. These are greater than array of I, right? So these are not the valid answers. So we pop all these elements until we get smaller one, or stack become empty. If this happens, and next previous element, next smaller element doesn't exist. If this is valid, then stack dot top is the next smaller element. That's it for the video. If you like the solution, please subscribe to the channel and hit the like button. Thank you.